Okay, everybody. I think we're ready to start. So welcome to the course. I'm glad to see everybody here early in the morning. And we're going to start out by, my plan is that we're going to introduce ourselves. Let's see. So I would like to go around the room, and maybe we could start with you. Is that okay? And I'd like for you to answer these questions up here. So first I want to know, where are you from? And do you have experience using WMS? What experience do you have using ArcView or GIS? And what do you expect to learn about this in this course? And maybe something about yourself. So first I'll answer those questions for me. And I'm from Utah in the United States, Salt Lake City, near Salt Lake City. I have a lot of experience using WMS. I've been working on WMS since 1994. And so for 21 years, I've been working on it. I work with Dr. Nelson, who began WMS. And I think he came here in 2001 and also 2004, and I came here both times with him. In 2004, we taught some Iraqis here, but in 2001, we taught in this room in 2001 or 2002. And I have also had experience with GIS, and for me, hopefully I can learn how to help you, and we can both learn in this course. My goal in teaching this course is just to help you to do the things you need to do so you can be productive. And something about myself is that I like to run. So we have mountains where I live, and I run in the mountains, and that's something about me. And so go ahead.
My name is Mustafa. I don't know more about WMS, but I know a lot about GIS.
Okay. Thank you.
My name is Muhammad Salah. I have no experience in WMS. I know little about GIS. I want to learn everything about WMS as I know. And I'm a partner of institute.
Okay. Thank you. Okay.
My name is Muhammad Mahmoud. I don't have experience in WMS. I have experience in GIS.
I'm Mona Yusuf. I have experience in WMS. I have a little experience in ArcGIS. I would learn everything about WMS in this course.
Okay.
And I studied my master degree in blockchain determination marketplace.
Okay. Great. Thank you.
I have good experience with and I think I did before at I don't remember if you came with the 2001 or 2004 we give training for Arab people.
Okay.
What I need for this course is to know more options and more option you add in the
Okay. Thank
near him. Norway. I'm also working here at the institute in water resources planning department. I have experience with RPD for a long time and recently projects for RPJS. I have attended the course in 2001 and another one in Iraq in Jordan. I hope to learn more options from WMS in a practical way, not only equal. For the moment, I think basically use equal in WMS. But I would like to learn like HMS. For example, if I would like to use something about reservoir management, is it possible using WMS? This is what I hope to do.
Thank you. Say the last thing one more time. Sorry.
I would like to learn more about the new tools which is available in this area and to see control programs.
Okay. Thank you.
Mano Ali, I don't have experience in WMS.
Okay.
I haven't any experience using WMS, and I didn't know about this tool, and I did some application using this tool. I haven't experienced at GIS company, and I hope that I learn how to deal with the paper based through the WMS.
Okay. Thank you.
My name is Islam Al-Zayed. First, I'm from Egypt. This is the first question. No, I doesn't kidding. First I have a background for WMS because I used it during my master's study. I have a master's degree from IT, this one institute in Cologne University of Life Sciences in Germany. I have a good experience in using ArcGIS. And I expect from this course, the only hydrological model that I use hit one within WMS, so I look forward to learning further about the other models for the hydrological, and for the hydronics I look forward also to know more about the sediment transport if it's possible.
Okay. Thank you.
I'm Ahmed. I used the WMS version 8 to solve a ton of problems and study the protection against fish flood in Sinai Peninsula. I learned it by myself, so it's a good chance to learn it from an expert like you. I have many goals I wish you can help me to learn. In WMS, I want to know more about how to calculate the erosion and sedimentation over the sand soil, and have a little bit knowledge about dam break analysis. I know it is included in WMS. Also, we are using some hydraulic extractions for achieving the protection, like culvert, maybe weeds, and artificial channel. So if we can simulate the flow within these structures, it will be very good support. For the GIS, alhamdulillah, I have good experience with GIS. These are my expectations, and I'm sure you are powerful and kindly enough to help us with this goal.
Yeah, I will. I'll talk. I'll try to talk about all those things. We'll see. But go ahead. So.
My name is Ahmed. I'm from Cairo, of course. I have an experience with many reasonable experiences dealing with WMS. And actually, when I first I saw you with kissing, I saw you before, and when you mentioned that you came here in 2004 and 2009, I attended that course in 2004. I was like, here at the time. of simulating the real case. So I'm looking forward to understanding how to simulate this case.
Okay. Thank you. Okay, well, so I would like to talk about the goal of this course is to help you understand how to do hydrology and hydraulics using WMS. And we are going to mention some GIS tools, but mainly we're going to talk about WMS and how to use that. And there are a lot of things that WMS does. It delineates drainage basins. It you can use it to create hydrologic models. You can use land use and soil data to compute curve numbers, which are used in hydrologic models, and also runoff coefficients that are also used. You can get a hydrograph from your hydrologic model. You can download data, and you can run HEC-RAS, hydraulic models like HEC-RAS, and there are some other hydraulic models that we'll hopefully get to talk about, like SWIM, that you can also run those models. Also, I want to give you an overview of Geisha, which is a 2D hydrologic model. It also includes a hydraulic model, so it's kind of a coupled hydrologic and hydraulic model. We're going to talk about Geisha and some of the things you can do with Geisha. And the way that this course is going to work, we're going to see how this goes today. Today I'm hoping mostly we're going to try to move quickly today, so we can review some things, and tomorrow maybe we'll have you start doing some workshops. But in general, what we're going to do is I'm going to have a lecture, and part of that lecture I'm going to give you a demonstration of how you would use WMS. And then after the demonstration, you'll have an opportunity to use WMS yourselves, and there's a workshop that you can go through and use WMS yourself. And then we're going to review what you learned in the workshop and in the lecture. And there's a course schedule. So if I go to, I have a course schedule here, and all of you, there were some thumb drives that I passed around. There are 3 thumb drives that should have been passed around, and those thumb drives have the data as well as the course schedule and also the WMS software on each of those thumb drives. And you're welcome to keep those drives. So this is the schedule, though, that we're planning on going through, and we're going to try to get through as much of this as we can. We have 4 days of topics here on this schedule, and then we have some additional topics. I think the first day, thank you. I'm going to try to, we might not do the workshops. So the workshops are for those who are not familiar with WMS on the first day. So maybe we'll try to skip the workshops, and I will show you some demonstrations on how you would use WMS to do these things. And then the second day we're going to talk about some things, and you'll be able to do the workshops. So there's also there's also on the, we have a bunch of PDF files, and these PDF files are kind of your manual. Now you don't have a printed manual, but if you look at these PDF files, there are some PDF files that begin with lesson. So right now we're going through this first PDF file. There's a workshop that's associated with this lecture. And so each lesson also, most lessons will also have one or more workshops. And you can just look through these whenever you want. You'll have them. You can use them. So that's your workbook. Now, are you guys, we're okay with starting at 8 o'clock? Or, okay, so we're going to try to start at 8 o'clock every day. And we're going to take breaks. How about breaks? Or when would you like to have breaks? Just maybe in the morning, one in the morning and one in the afternoon. Is that okay? All right. And then for lunch. Okay. All right. And for the workshops, you can work on your own computers, or if you don't have, it looks like everybody has their own computer. If you don't have your own, you can work with a partner. And if you get a phone call, of course, just step out. And we also offer continuing education units, which I don't know if that matters here, but the purpose of this, I'm just here to help you with the things you need. Okay, so let's talk about how you would use WMS. So I'll start up WMS here. And hopefully everything works. We'll see how this works. Let me make sure this is the correct version, so we're okay. All right, let's say that I'm interested in modeling an area, and you don't have to worry about the exact steps that I'm doing right now. I'm just going to show you how you would use WMS to delineate a watershed. So if I want to use WMS, the first thing I can do is I can just select this tool, Get Data from Map. And WMS will bring up this tool here. It allows me to select an area that I'm interested in. So let's, what's an area that you're in? Somebody mentioned Sinai, I think. So let's go to the Sinai. And maybe we're interested in the area around, maybe down here, Sharm el-Sheikh. Is that how you say it? Sharm el-Sheikh? So maybe we're interested in that area. Let's download some data for that area. And so to download the data, you just select the area that you're interested in. You just go to wherever you're interested in, hit OK here. And then WMS will come up with some different options for downloading different types of data. So let's say that we want, some of these data are only available in the United States. I'm going to download this SRTM data, which is available anywhere in the world, as well as just some imagery. So I'm going to select the SRTM data. The SRTM is just some elevation data. It's 90 meters, so it's not very accurate, I guess, but it's as good as we have in WMS. There's also some more accurate elevation data called Aster GDEM version 2, I think, and that is 30 meter data. It's better information. I actually on your thumb drives, one of the files on there has some Aster GDEM data for Egypt, but it's just for the Nile Delta, so it's not for the whole country. Okay, so I'm just going to save these files out. Let's create a folder called Demo for demonstration, and we'll call this Sinai. And then WMS asks me to create these files. Okay, so WMS will ask me what resolution I want. Like I mentioned, the SRTM is about 90 meter resolution. So I can enter that, or I can just use whatever WMS comes up with. And then it'll download this DEM data, hopefully. I haven't tried it yet here, but we're hoping that it works. And if this doesn't work, then I have a backup, I guess. Is it really slow? Okay. Okay, well maybe I'll, okay, here we go. It looks like it's able to download the data. So here's the DEM. For the image, I'm going to just do a larger resolution so it doesn't take as long to download. So you can see here on the screen, you see these lines, and the lines are just contour lines of from my elevation data. So WMS is just creating these contour lines. This is, of course, the Sinai, and then the sea here. But let's just delineate one of the watersheds in this area. So I don't know, I think Sharm el-Sheikh is down here, right? Somewhere down here. So to delineate one of the watersheds, I'm just going to run through some commands. The first thing is I compute where my streams are located. And I'll run this program that computes that. And WMS will compute these blue lines that you see on the screen. So I can zoom here and look at these blue lines. And those represent where streams could be located. And so let's just delineate. If I create an outlet point on one of these watersheds, I can delineate one of these watersheds. So I'm going to create an outlet point, and then we're going to run through the delineation. And so there's a watershed, so 35 square kilometers for this watershed. And then I can take that information and then I can run any of the hydrologic models that WMS supports. So if I look here, this is the hydrologic models module. These are all the different models that WMS supports. And a lot of times if you're able to compute data for one of these models, you can set up, the other model is very easy to set up. So once you set up one of the models, you can run any of the other models, or most of the other models, with very little effort. So that's WMS. That's how WMS is used. Are there any questions about that? Don't worry too much about the specifics. Yeah, Iman. Okay, so you're wondering if the 30 meter or the 90 meter data is better? Well, it just depends on what you're doing, but you've tried the 30 meter data and the results are not as good in some areas. Okay, Yeah, so it just depends. If you're doing a really large basin, like this one, then maybe the 90 meters is fine. But maybe for smaller basins, and you would want to use the smaller cell size.
I'm talking about accuracy.
The accuracy of your delineation.
Because I sent email before maybe 5 years ago to someone asked about the distribution and said this meter is supposed to be bigger than 90 meters, but they tell me this is the VM which I used to identify, maybe there's something else. But I
Oh,
think
so-
about available through the internet is 6 meters.
So you're saying maybe the 30 meter data is not as good as the 90 meter. That could be, I don't know. I don't have enough experience with Egypt, I guess. I mean, you would probably know more about that, about the 90 meter versus the 30. But the best data that's available is the Aster GDEM V2. It's version 2, I guess. Data. It's the 30 meter data, and that's the highest resolution. But I don't know if it's as accurate as the 90 meter data. So anyway, sorry. But you could use either one. You can use either the 30. Does that, I don't know, did I help you with your question at all? Or?
Yes, I really like the VM which you mentioned now.
Uh-huh.
We have a problem
Uh-huh.
with data.
Uh-huh.
So maybe I can take it.
Yeah, we can try it. We can try delineating a sec. Maybe we'll try it later today or tomorrow or something, and we'll see how it goes. So let me quickly, I'm just going to give you a history of WMS. WMS was developed at BYU, that's in Utah, where I'm from, and it was developed there in the early 1990s, and it was first released in 1994. That's when I started working for WMS. We were sponsored, the software was sponsored by, well, we sell it, so we sponsored the development, but also it's sponsored by the U.S. Army Corps of Engineers. They have provided us money for developing WMS, as well as the U.S. Federal Highway Administration. And it's also distributed by us as well as the Federal Highway Administration in the U.S. and also the Army Corps of Engineers. So what can WMS do? Well, I've kind of shown you some of the things that WMS can do. You can download data and you can delineate watersheds. It can also do, so that's hydrology stuff. It can also do hydraulics, so you can do river modeling, and you can do two-dimensional hydrologic and hydraulic models in WMS. And so you've seen how WMS can compute a watershed delineation, and this is an example of a map that you can create in WMS. Also, if you have CAD data, you can bring your CAD data into WMS and look at your watersheds in there and run a hydrologic model from your CAD data. The purpose of WMS is to convert GIS data into a hydrologic model. So here I have some GIS data, and I've computed my geometric parameters. These are some of the geometric parameters that WMS computes. And so all of these letters here, A means area, so that's like the watershed area. It computes distances and geometric data for your watershed. And then from those parameters, those can be transferred to your hydrologic models. And WMS supports several different kinds of hydrologic models, but a lot of the models are what we call lumped parameter. Now, do you understand lumped parameter models? Lumped parameter? Everybody understands that, or some don't? Okay, so with lumped parameter models, you combine all for each subbasin in a watershed model. In this watershed model, I have 3 subbasins, and so for my 3 subbasins, I've computed several parameters, and I take all of those parameters and they're all lumped together as a single parameter for each subbasin. There are other kinds of hydrologic models called two-dimensional hydrologic models. They're also called distributed hydrologic models. And for those types of models, you define parameters for several points in each subbasin. So a subbasin is divided into a bunch of little cells, and for each of those cells, you define a set of hydrologic parameters. But in general, in WMS, you're going to run something called a lumped parameter model. And the lumped parameter models you see here that you can run from WMS, HEC1, HMS, there's something called TR20, TR55, the rational method, NSS, and HSPF. Those are some of the hydrologic models. Those are all lumped parameter models. So WMS computes hydrologic information, and it also computes geometric and hydrologic information. The hydrologic information that WMS computes that we'll be talking about include the time of concentration and the lag time, and also your curve number information. You can also use WMS to define your rainfall data. So here you can see a map of rainfall gauges, and for each gauge you've defined a certain rainfall value, and then WMS will use those rainfall values for your hydrologic model. It also computes something called the time area curve, and that's used in the HEC1 hydrologic model. It also does reservoir computations. Somebody mentioned that they want to do reservoir computations. We'll look at those, how to do the reservoirs. It also does snow melt. I don't think snow melt is a big issue in Egypt because you probably don't have a lot of snow here. It also has these calculators: detention basin, weir flow, curb and gutter, and channel hydraulic calculators, as well as culvert, some interfaces to culverts. WMS also computes hydrologic parameters, so it supports several hydraulic models. The hydraulic models that WMS supports are HEC-RAS, SWIM, and a model called simplified dam break. HEC-RAS, a model called SWIM, SWMM, and then a model called simplified dam break, which is used for dam break analysis. You can also link your hydrologic models to your HEC-RAS model, and there are different ways of doing that. You can also compute a floodplain delineation, so you can create cross-sections, cut cross-sections in WMS for your hydraulics, and then delineate a floodplain from your HEC-RAS results. Also, WMS does post-processing, so you can look at hydrographs that were computed and just view those hydrographs. You can look at output files. So these are some output files from running different models in WMS. You can also export your WMS models. This is a watershed model that I did in WMS, and you can export that to GIS. So this is ArcGIS, ArcMap, and you can export your models from WMS to ArcMap using the shapefile format, and also geodatabase. You can export a geodatabase to ArcMap. So this is the overview of kind of what we're going to talk about in the course. First we're going to talk about how to get data and the different kinds of data. Then we're going to talk about how to delineate your watershed and how to compute hydrologic parameters. And then we're going to discuss how to look at your results, different ways of viewing your results. And there are a lot of different things we have planned to talk about. I don't know if we're going to get to everything, but we'll see what we can do. So first we're going to talk about getting the data, then developing your watershed model, and then looking at your results. So when you bring up WMS, this is the screen that you see. And you all have this slide. I'm going to let you look at this slide when you, just whenever you want. You have it. But the most important things about WMS to remember is that these are the menus up here at the top. And these menus, as well as these tools here, so these are the tools that will allow you to do things in the graphics window. So the menus and the tools change based on which module you have selected. If I select a different module, then my menus are going to change. So you may wonder, well, how do I do a certain thing in WMS? Well, you can look through you can go through and change each of these modules and try to find the menu. Another thing you can do with most objects in WMS is this is the Project Explorer. And if you right-click on things in the Project Explorer, right-click on the icons in the Project Explorer, then it will allow you to do different operations with those objects. And so those are probably the most important things about WMS. You have this units toolbar. These are the properties. If I have something selected in the Project Explorer over here or in the graphics window, then what is displayed in this properties window, it'll show me the attributes in the properties window. So that's, and we're going to learn how to use WMS throughout the course. This is the WMS window, like I said, and there are different options for getting around. Probably the hardest part that people have is just learning how to get around in the WMS interface. Once you learn it, I use it all the time, and I program WMS, so it's very easy for me, but maybe for you, if it's your first time using WMS, it might be a little bit difficult. If you have a question, you can always go to the help command. If you go to the help menu, there's a WMS help command, and that will bring up a website called, let's bring it up here. So there's a website called xmswiki.com. And xmswiki.com, XMS stands for, Aquaveo develops 3 different software products. One of them is called WMS, another is called GMS, another is called SMS. So WMS is watershed modeling, GMS is groundwater, and SMS is surface water modeling. And so XMS, X stands for WG or S. So it's XMS Wiki, and it's just a kind of like Wikipedia, except it's a wiki where it's kind of our help page. And so if you have questions about WMS, you can go to this XMS Wiki, and then there's this help page that has pretty much all the information you need to know about WMS. And that's the WMS help. So let me just show you a couple more things about WMS. One of the things is like I mentioned, if I change, these are the modules up here. So if I change the module, then you'll notice that two of the things change in WMS. As I change the module, this menu up here changes, as well as these tools over here. So these tools, these are called the dynamic tools. It's called the dynamic toolbar. This menu, you can call it a dynamic menu because it changes when the module changes. Okay, so I'm going to change these modules. You see how the menu up here changes as well as the dynamic tools. The other thing you can do is if I select an object over here, this is something called a DEM. This is just my elevation data. You can turn those on and off. So if I turn it off, you don't see the contours there anymore. And if I select an object, then WMS will change modules based on which object I select. So if I select something under this map data, it's going to change to the map module. If I select something under hydrologic data, it's going to change. WMS is going to change to the hydrologic modeling module, and so on. So I have all these different folders. The module changes based on which folder I select. I can also, if I right-click on one of these data sets, there are several options that allow me to do different things. Like, for example, if I want to save this DEM in a different format, I can right-click on that and select Save Digital Elevation File. And there are all these formats that I can save this elevation data to. There are different formats, so I can convert between formats. Okay, so there are a lot of things. The other thing is that I want to show you is this toolbar. Any tool that has an arrow means if I select one of these tools with an arrow like this tool here, that means if I select in the WMS graphics window, this area, the big area in the middle of the window here, that's my graphics window. If I select in the graphics window, then WMS is going to select something if I have an arrow tool selected. You'll also notice when I select something that it shows attributes of the thing that I select over here in the properties window. And also if I select something, I can right click on that thing and go, usually there's some attributes for whatever I select or whatever. If I have a tool without an arrow, that is usually used for creating something. So, for example, if I select this tool, this is the Add Vertex tool. And then if I click in the screen, the WMS is going to create something. So I select here, and it's going to create a vertex in the screen, which maybe I don't want a vertex. Maybe I do want a vertex, but if I select in the screen, since I have that Add Vertex tool selected, it's going to create something. I'm going to hit cancel here. Let's say I don't want that created, and anyway, you can play around here in the WMS screen. But so any tool with an arrow is selection. This tool, and this tool, those have arrows, and then each module has a set of tools. So this module, I have these tools with arrows. Anything without an arrow, with no arrow, that's used for creating something in the graphics window. Okay? So are there any questions about the WMS in general, the graphics window, modules? Yeah. Over here in the properties? Yeah. Yeah, so I can select something. I can select whatever I want to change, and then go here to the name, and we'll just change this to whatever, Sinai. And that'll change the name on this data set. the name of the basin. So that would be in the hydrologic modeling module. But yeah, you can select the basin, then you can come over here, and we'll call this Sharm. How do you spell it? Sharm. I don't know how to spell it. So you can change it. It'll give you an error. Yeah, so
Name with different order, if I want to say, season number 3, start from 3, don't start from 1. And I want to change the name of the basin, not that are numbers, not character names, just numbers.
yeah, so the name.
Sometimes give problem. It doesn't understand
The only time you would have problems is maybe if you were to enter Arabic characters for the name of the basin. If you did that, then you might have a problem. But other than that, it depends on the model actually. Like most of the models in WMS, you can, or some of the models like HMS, you can name the basins whatever you want. One limitation with HEC1 is you have to have 6 characters or less for the name of each sub-basin in your watershed. So if you have like Sharm el-Sheikh wouldn't work because it's more than 6 characters, too long. But that's just a model specific thing. In general, you should be able to name it whatever, each basin, you can name them whatever you want. You cannot have 2 basins though with the same name. So if you have 2 basins with the same name, then WMS is going to have problems. You would want different names for all of your basins. Any other questions?
But the rest of the hydrogen models are not, I don't know if it's suitable to use for our area and area, and they contain specific information or database about some area in like TR20 and TR20.
Okay, so you want to know what models could be used here?
Yeah.
Okay, so you can use, we can go through. You can use HEC1, HMS is fine, TR20 is okay. I would not use TR20, but it's fine. TR55, the problem with TR55 is it is US specific, so don't use TR55. NSS, also the same thing. NSS is a statistical method that was developed only for different states in the United States, and so it's only used in the United States. Rational method should be fine. ModRat you would not use. ModRat is for a place called Orange County in California, and that's really the only place that it's used. And OC Rational and OC Hydrograph, that's the same thing. It's only for California. Okay. HSPF is fine to use here, and SWIM is also good, a good model. So I guess the models you would use is SWIM, HSPF, Rational, HMS, HEC1, and then maybe TR20. But I would not use TR20. HEC1 is going to be much better, or HMS.
I knew that HMS is working mainly on HEC1. So I think they are the same model. Is there a difference between HEC1 and HMS?
Yeah, so HMS is the newer version of HEC1. And so HMS is kind of replacing HEC1. So in the future, especially in the United States, people are using HMS instead of HEC1. HEC1 is, they stopped developing HEC1. It's no longer being developed.
So it may be better for us to move from HEC1 to HMS.
Yeah, you can move from HEC1 to HMS, but they're different models. They do have there's a lot of similarities between the models.
I knew that HMS is not a software. It is using the HEC1 mainly. Everything in HMS is HEC1. There is no difference in the mathematical relationships within the HMS.
Well, HMS has, so there are two separate models, but HMS has some things that HEC1 does not have. And HEC1 will also have a couple of things that HMS does not have. Yes. I mean, so for example, HEC1 has uses something called a time area curve, and HMS does not use the time area curve. HMS has something called, you could actually do 2D, we call it quasi 2D hydraulics in HMS, and you can also do long-term quasi 2D hydrologic modeling, sorry. You can also do long-term hydrologic modeling in HMS, but HEC1 is not designed to do those things. So there are two different models, and HMS is the newer model.
So HEC1 is more as one storm model, but HMS we can use it for river hydrology.
Yeah. HEC1 is a single storm model. Yeah.
So HMS is better for river engineering.
HMS is you can do single storms, but you can also do long-term modeling.
Both are available with HMS.
Yes.
Which is also the previous thing we used to say has WPR.
Yeah.
Now we have WPR in version
So a WMS is just the newer version of the WPR. WPR stands for WMS project file, and maybe a few years ago we changed it to a WMS file because it's just a different format. Right. Just save. The default is just to save it as a WMS file. So when I save it, it's going to save a WMS file. And you can still save it as a WPR, but yeah, you can still open the WPRs. Mm-hmm.
Especially for the station definition. Because in the old version, we can define the coordinates of the station. In the new version, we have to define layers from the station. So if I define the station in this version 3.1, when I open the new version, I don't see
The station?
The location of Rainfall station.
Oh.
So you define location by adding the word which you mentioned now, that will necessarily create layer this location. But when you open this file, the newer version of WMS, and it doesn't show.
Oh, really? So I didn't know about that, but if we could look at those files, maybe I can look at the problem and we can see if we can fix it. Okay.
One thing is we don't mention the initial presentation of the station. We go through this. how to define rainfall gauge?
How to define rainfall gauges? Yeah. So it's very simple actually. So like for example, if I wanted to define rainfall gauges here, I would just create a rainfall gauge coverage. So these are the different coverage types. Here's a rain gauge coverage. And then I would select this tool. This is the add feature point, create feature point tool. And just wherever I have a rainfall gauge, I can do that. I can add a gauge.
How can I enter the location rainfall? That was the
I have already defined the location for this point.
Oh, okay.
So how could that compare these locations?
So do you have them in, you just have the X, Y points? Okay. Well, you could.
point and you define the coordinates. That's what I did before. I put the point and then I go back, I take on the station and I define the
Yeah.
coordinates.
You could do that. You could select, if you know what the coordinates are, you can go over here.
Yeah.
You can define the points and then you can change the coordinates. Maybe this is 6, 1, 5. Oops. 5, 7, 0, 0 instead of where it is, and just manually change those coordinates. If you know approximately where it is, you could point and click and create them and then change them. Another thing you could do is just, if you have just an XY location, let's see, let me see if I have this file.
So you can have layer. If the layer has already the location, rainfall station, then you can have just this layer.
Yeah.
And define it as rain gauge layer.
Mm-hmm.
A shape file, you can open a shape file.
Yeah, you should be able to open a shape file of X, just a point shape file, and then you can convert that to map data coverage, a rain gauge coverage. If you have just XY coordinates, you could probably read in a text file of XY coordinates. And I don't know the specifics, but there's a way to do that. I'd have to play around with it to see what the options are, but for sure you can read in a shape file if you have a shape file. You could also just point and click like this and change the coordinates.
Does it gives every rain gauge station the depth, the elevation of the depth, which is already defined in another layer?
Does it use the DEM?
Yes, to add the depth, consider the depth, the elevation of rain gauge, each rain gauge. There is a big difference in rain gauge's elevation.
Mm-hmm.
It can be read from the depth.
Uh-huh.
Some rain gauges you put over the mountain, others on the shore.
Uh-huh.
So does it consider the difference of elevation when it calculates the rainfall over the data ownership?
So in WMS you would just define the depth of rainfall. So for example, for each gauge you would define a total precipitation value. So it doesn't use the DEM. It doesn't use the elevation.
What it means that if the WMS take into consideration where do you put the rain gauge? So if you put one in 100-meter elevation and the other one is
At sea level.
yeah.
Yeah.
So yeah, would make difference.
The altitude would make it would make a difference in the rainfall, and so you would just enter the different rainfall values.
Because the growth of the increase in volume.
Uh-huh.
Increase in volume doesn't assume it assumes the land is flat,
Right.
which is not.
After the
So-
2D here, I think you cannot, right? When we add a point, it's 2D. You just add x, y, it's a point.
Yeah.
WMS doesn't know the altitude.
Yeah, we're not considering the altitude. We're just using the Thiessen polygons to determine the percentage of percentage of your watershed that each rain gauge covers. We're not using elevation data at all with the rain gauges.
I think what you mentioned, the altitude difference will affect the rainfall, but it will be already in the value of rainfall in this station.
Yeah.
It will count like that. So if it's in high elevation, the rainfall amount will be different than one in the lower part. And this is what will appear in your model. But in basin, you just, as you mentioned, you take the percentage of the basin for the basin. As far as
But I think it makes a difference. It should affect the total amount of rainfall over the rain.
Yeah, the elevations would, and the fact that you're in the Thiessen polygon, a lot of times the Thiessen polygons will, like this gauge, maybe it's at a higher elevation, and the area that this gauge, the percentage of the watershed that's attributed to this gauge inside the Thiessen polygon will maybe take part of that elevation data into account, but we don't consider elevation data at all in the.
Is there
you will not use basin for it. There are other methods to apply to count for the elevation of the point rather than basin for it.
Yeah.
it should be considered in the weights. It should be relative weights of each rain gauge from the point of view of the elevation.
Yeah.
I mean the rainfall over the north should maybe look more weight than the lower altitude one.
So the other method I can call it.
Is there more sophisticated way to calculate the area and the rainfall?
Yeah. So some of the other, you can do radar data. You probably don't have radar data here, right? So you can do that if you had it. You can also do inverse distance weighted. That's another method, but that doesn't use the elevation data. So, but you can, if you have a way of computing the percentage of each gauge that you want to attribute to your watershed, and it considers elevation data, then you can use that method and just put in the percentages in WMS. It'll let you do that. But WMS does not consider the elevation data itself.
You can create a shape file.
Yeah.
Using any creating or any other methodology, and for each polygon you can assign a value for rainfall.
Yeah.
And then add the shape file to WMS and then divide it.
Well, you can't do the polygons. You still have to do the points, but you could compute the percentages using using different polygons. But so, I mean, another thing I should tell you is that WMS has a tool. WMS has a tool that will allow you to download rain gauges from the web. So I think you probably have some rain gauges for Egypt. This is from HMS, the HMS meteorological model. And there's an option to download daily precipitation. I don't think they have, you don't have hourly precipitation. Do you have hourly precipitation gauges here? Maybe you do, but we don't have access to it. You do have it? I don't think we have access to it though. So we don't have access. The data is not online. And so, I don't know, maybe this is not very useful. But like if I go search for 500 kilometers. So these are the stations I get. There are these different stations. Some of these are Egypt. Yeah. Here's one in Cairo. But so these are the different stations I can get. These are just daily rainfall values. Okay, so this is another way to get. Yeah, these, I don't know whether they're ground stations. They're through the U.S. National Climatic Data Center. They get a bunch of data for different parts of the world. And these are just daily rain gauge stations. But let's just select a few of these maybe. And oh. Some of these don't have recent data. Like this one only goes until 1957. Down here, this is the latest date. So I can't really use that. But I can select these first two. And then WMS is going to download it'll download precipitation for, you specify the dates, and WMS will download the precipitation. I'm not going to do this because it takes a long time to download, but that's an option. WMS will create these gauges. It creates it's time series data. So time series. It's time series. Is there gridded data? No, not for Egypt, just for the United States. All right, so are there any other questions? Do we need to take a break, or is everybody okay? Can we move on? What do you think?
If you would like to drink tea or coffee,
I'm going to drink a little water.
we can bring you some juice.
I'm okay. I like water. Water's good. Yeah. I have some juice. I don't drink tea or coffee, but I'll drink the water or juice. I prefer water, I guess. Water is good.
We have also kind of like green tea or some other herbs you would like also.
No. Just water, maybe juice, but mainly water. Oh, we need to stop.
No?
Just for a couple minutes. So hit F10.